Hello everybody, my name is Dennis Shilin. I am a researcher at Federal Scientific Agro-Engineering Center BIM. My talk topic is identification of the cow's nipples using a 3D camera with TOF technology. A three-dimensional time-of-flight camera or 3D TOF is a type of non-scanning LiDAR, a device for detecting, identifying, and determining range-used light, which uses powerful optical pulses or several nanoseconds durations of accuracy depth information, usually at short distance within the region of interest. Time-of-flight cameras are most often used as follows navigation in a confused space, gas recording, scanning objects, tracing objects, measuring volumes, monitoring the target areas, and fast, accurate, and digital of distance to the target. Augmented reality evaluation of the size and shape of objects. So, the first smartphone with a TOF camera was the iPhone X, released in the fall of 2017. It's a key element of the Face ID system that scans the user's face. In 2015, with the help of a drone and a camera with a TOF technology, a three-dimensional image of the statue of Prince Severus in Brazil was successfully created. Priori to this, an exact model of this statue didn't exist. TOF technology is used not only on drones and telephones, but also in various areas such as logistics, surveillance and securities, robotics, medical, games, photos, film production, auto industry, archaeology, some environmental projects, and farm automation. So, in the framework of this article, the questions of using a 3D camera to detect a biological image in the form of nipples of an udder of a cow in considered. Automatic identification is necessary for automated milking of an animal. This slide shows automated milking plants in exotic automatic milking systems of various manufacturers, including Lely, Gear Farm, Delaval. There are drawbacks associated with the alternately putting on milking cups with a long time interval, which contribute to reducing the release of oxytocin due to delays in the stimulating effects on the nipple receptors, which leads to the incomplete elimination of milk from the alveoli. Moreover, the advantage of such system is the absence of need to search and analyze all biological objects in the same time. The relations of this work is the development of an identification algorithm for all of nipples of a cow, with the aim of future analysis in the formation of position points for the working bodies of the milking robot, the kinematics of which allow positioning is at all desired points at the same time. So, such installations can consist of milking links, manipulators driving in motion by a pneumatic or electronic motor. In the work of Dorohov and it's all the questions is just been considered of choosing the kinematic model of such manipulators and the location of the drive equipment to ensure the required reachable areas of the working body. So the solutions of the kinematics problems is considered by Gannon, and so the authors development in algorithm for solving kinematics problems with provides for scaling when changing the design parameters and the number of manipulator links. The search of a solution to kinematic problems is based on a neural network approach in combination with the numerical refinement algorithms. An important part of the automatic milking system for calls is the automatic nipples recognition system for the call. The talks is not effectively solved with the help of technical vision, since the case is necessary to know for sure the necessary threshold value for the preparation of the original image in order to detect the desired objects. So this picture shows the result of the preparations of the original image. This slide shows descriptions of the experimental laboratory stand. The testing of the developed algorithms was carried out of the laboratory bench shown in this slide in the OZX plane. A plastic adder model was used as the object adder study, and a 3D TOF camera was used as a camera. There are hardly number of cameras with TOF technology. The detailed comparison is present by Jacobson and Rillick in this work. And in this work, we use IFM 03D303 capable of capturing an image in the format in real time with a frequency of 25. The device has a working range from 0.3 meters to 8 meters and provides distance information in real time. A detailed discussion of the camera can be found in Bogarts. Various techniques and techniques for processing signals from a TOF camera are disclosed in code. Recognizing the objects in the image alone is not a note of the full functioning of the system. It's also necessary to know the location of the objects found relative to the central reference frame. This is another reason to use an industrial camera with the ability to visually assess the distance 3D camera with the TOF technology. Knowing the aperture angles, these angles you can see in these pictures, and better along the axis OX and OY of a camera allow to build a point cloud in the space OXYZ. In order to automatically recognize biological objects in the form of nipples or the adder of a call, it is necessary first to define a cloud of points of the adder itself. This slide shows defining another points cloud. In the exciting and developing milking machine robot, 3D camera which serves as feedback when controlling the position of the working bodies is installed near the objects as shown in this slide. This arrangement ensures the location of the other points in the center of the entire cloud points and at the closest possible distance to the camera. In these slides, points A and B are adjacent points. The distance S between them increases with increasing distance between the camera and the tracking objects. According to the foregoing and experimental range of values O to C was selected with selected which eliminated all points of distance between which exceeded the permissible values of S. The range set by the operation of from O to C guaranteed to screening all the other points, and the distance between point A to B is calculated using the following equation, where x, y, z with A is coordinate from points A, and x, y, z and from B coordinate of point B. So, if the value of S is within the admissible value that is set by the operator, the entire series of points from A to B will enter the objects, and the verification of the points belonging to the cloud and terminated in this case the cloud number that was indicated earlier at point B is assigned, or a new number is assigned, and you can see in these pictures. And at the pictures, the location of the adjacent points with the point A. So, if the value of S is not in the acceptable range from O to C, then a similar verification of the distance to the point B, C, D, K, L, N, M pair follows. This slide shows an example of points cloud search algorithm. So this picture shows an example of the work of the approach for searching points clouds. Checking points is carried out diagonally provided, and earlier the check was not carried out and not a single cloud of points was formed. For the first points, the admissible value of S was calculated to point B. You can see in these pictures, yeah. The second to the point D, the third to the point P, the fourth to the point L, and the fifth, the admissible value S was not found in all available points. This picture shows that as a result of testing the algorithm, 3 points clouds were found, the largest of which is marked with a red frame. This slide shows all the points that fit the specified requirement, where the purple color indicates the points that do not exceed the allowable value of S on the diagonals, blue, or on the horizontal and vertical. Since the 3D camera installed of the smallest distance to the largest point clouds, we will appoint cloud consisting of co-under points. So this slide show in red refined cloud of a co-other points. The aforementioned refinement has an important merit. For example, this pictures shows the after identifying the largest points cloud, information about the 4 nipples didn't fit into the cloud, while the identification of this cloud made it impossible to fill in the last data. And in this case, there may be cases with negative effects. You can see in these pictures when the points clouds contains artifacts. This slide shows defining co-nipples points clouds. In these pictures, you can see in the left and right search for an area with the maximum number of points. And in these pictures and the left pictures, you can see zones described around the centers of the points clouds found. And the right pictures, you can see fixation of the point clouds, each separately the nipple of the animal. In these slides, you can see all conclusions in this work. So, thank you for attention.